All right, because of the mechanism of the reaction, we actually get some interesting stereochemical outcomes. And so let's take a look at this alkene and what happens when we add some borane and then oxidize it. If we think about one of our intermediates that we have, we're going to get what's known as syn addition with the BH. Right, so this is known as syn addition because they add to the same side. And then after the reaction, after the second step, this borane is then going to be oxidized. But if you look at the mechanism there, we have no rearrangement of this carbon. All we're doing is switching out this borane for our alcohol. And so what we have here again is syn addition. And so what that means, our products here can be one of two things, right? We can add the hydrogen and then eventually the alcohol from the top of the compound or to the top of the alkene. Or we can add both of them from the bottom of the alkene or underneath the alkene. So we get those two products. But then if you think about some other products that you might envision, right, where our H and our alcohol have added anti to one another, we can't get that because the mechanism won't allow it, right? So you don't get that compound, and then you don't get the enantiomer of this compound either. Right, so none of this, it must go through this syn addition, right? So the hydrogen and the alcohol must be added across the same side. And so when you have the creation of one stereocenter, right, when we add our hydrogen and alcohol across one stereocenter, the borane can attack from the bottom or the top. And so what you end up here with is a racemic mixture. Right, because here we only have one stereocenter being formed. However, in the example with our methyl cyclohexene, if we have multiple stereocenters being formed, we only get the syn addition. And so if we add from the top, right, this is the attack from the top, we get this product, or our borane can be added from the bottom or underneath the alkene. Then we'll get this product. But you notice, again, we are adding the hydrogen and the alcohol syn to one another, right, on the same side of one another. And again, we do not get any case in which we have anti-addition. So just some stereochemistry to think about this reaction as well. And again, all of this comes from the fact that we add this H and this BH2 syn to one another, and then that this BH2 gets replaced without changing the stereochemistry whatsoever.